We've reached our last session. So if for those of you who've been hanging out with us all day, we are really excited about our next session that is a group of virtual tours. And sorry, I'm just kind of getting my bearings here. We're going to highlight some facilities from the College of Ag and Life Sciences here at UW-Madison. Now, UW-Madison is our virtual host for today's Dairy Summit. We move it around between our 3 partner schools, and this year is Madison's turn. And so we're going to be highlighting some research facilities in the College of Ag and Life Sciences. And to kick it off, I am pleased to welcome Mark Rickenbach. He is the Senior Associate Dean and Interim Associate Dean for Research. And in this role, Rickenbach is responsible for administration, management, and supervision of the college's research enterprises. So with that, take it away, Mark.
Thank you, and good afternoon, and thank you again for joining us today. We are excited about the opportunities brought about by the Dairy Innovation Hub. Today's summit has showcased some of the research activities, while the panel's discussions have addressed both opportunities and challenges moving forward. Dairy research in CALS is diverse and depends on varied infrastructure. This panel showcases 5 distinctly different facilities with a shared purpose to improve dairy. Each provides resources for teaching, research, outreach, and collaboration as it relates to the Dairy Innovation Hub mission and vision. Some of you may have visited these facilities in person, and we are excited to highlight these spaces that are critical to the work of the Hub in CALS. After the presentation, we will have some time for questions. With that, I'd like to kick this off with a building update on the new home for the Center for Dairy Research with John Lucey, faculty member in Food Science and Center Director. Take it away, John.
Thank you, Mark. I'm very pleased to be able to show you some important details about our new Center for Dairy Research building. We have a short video overview of it. But in introduction, this is the culmination of several years of work and construction and design. And by this weekend, 2/3 of that new addition will be turned over to CDR to start operations and start research in there. So that's a very exciting milestone that's coming up. The whole building project has about 77,000 square feet of new or remodeled space and has kicked off into the next phase of the project, which will be the renovation of the Babcock dairy part of it, which will continue until next summer.
We will enter
this project is very important for us as it provides processing pilot plant spaces to do our research, including all kinds of interesting cheese vat and cheese making equipment and ripening rooms, and then looks also at beverages, cultured products, and powder. So it really covers a wide range of value-added dairy products. And the ground floor has training program areas, especially for helping train farmers or industry folks with new short courses or programs. So with that, I will hand it back over and we'll have a look at the video and we'll be happy to answer questions afterwards.
On the ground floor, we will enter from the street at Linden Drive. The donor wall is immediately in front of the entrance lobby. You can go down that little stairs to be in the atrium, and beside that is the new training center. If we go down the corridor at the back is the new kitchen and apps lab. Visitors to the new CDR second floor offices would take the stairs near the donor wall to go to that second floor area. Right at the entrance to the new CDR building, on this porcelain tile area, we will have a donor wall, which will recognize all the donors from largest to smallest, without whom this wonderful facility would not have been possible. The Saputo Atrium is a pre-function area for the training center. It will provide a place to gather, chat, and take breaks, and we'll have a serving area for our lunches and food. The state-of-the-art Sargento Training Center is almost complete, and it will hold close to 80 industry attendees at any short course or training meeting. It will have a screen at the front of the room backed by porcelain tile, as well as 2 whiteboards on either side. Every table and seat will have power for laptops, phone, etc., and an AV system can show cameras of activities in the pilot plant or tasting sessions in the kitchens. Down the corridor from the training center is the new culinary kitchen and application lab that will be for training purposes. Here we will do the labs for our short courses, taste products and bake pizzas. The lab contains various types of cookers and kitchen equipment to allow CDR and industry to test new formulations or evaluate product performance. At the back of the kitchen is a prep area with sinks and dishwashers, as well as a walk-in cooler and walk-in freezer for storing various ingredients. We will also have 6 new sensory booths to evaluate products. Each booth will have its own sink as well as a computer for scoring products. The flooring is a very nice and durable terrazzo with attractive tile for various areas, including nooks for recognition or other dairy memorabilia. There are also new bathrooms on this floor. We can go up the stairs by the donor wall to the new second floor CDR offices, or we can take the stairs behind the training center to the first floor processing areas. Here is a floor plan for the first floor areas. Right after you come up, the raw room is directly in front of you, and the APT vats are on the right-hand side. The north side of this floor contains the natural and specialty cheese areas as well as all the ripening rooms. We will have 2 new 2,500 pound enclosed horizontal cheese vats from APT, as well as a drain table for them. Perfect for training operators or conducting real-world trial. The CDR will have its own raw room for processing, blending, and standardizing all the different types of unique milks needed for the facility. This will include 3 raw milk silos, 5 batch tanks, a milk separator, several valve clusters to simplify process flows, a homogenizer, and a pasteurizer that will have regular hold time as well as a long hold tube needed for products like yogurt. We will have a testing lab attached to the raw room, which is where we will have our FOS units and can quickly standardize milks. In this first floor cheese area, we will have 4 Relco vats that are each 1,000 pounds. Those vats will allow us to program specific recipes and precisely control operations like heating and stirring. They will be on load cells to help us do mass balances and cheese yield studies. Each Relco vat will have its own drain table for finishing the curd. The CDR facility will have its own loading or service dock to bring in and out equipment or materials. The new milk receiving bay will allow us to receive milk from our trucks and pipe it directly into the silos that are in the CDR raw room of the new addition. We will have 9 cheese ripening rooms or caves, each with its own air conditioner to control things like temperature, humidity, and airflow. They can be set to the exact conditions needed for all types of specialty cheeses, from the mold ripened to Alpine style and beyond. The specialty cheese program will have its own separate make room area and its own cheese vats. Here is the layout for the second floor, which contains all the non-cheese program areas. The south side has the high bay area for equipment like spray dryers. The aseptic beverage program is on the north side, but on the west side of the room, with the membrane and cultured products areas on the eastern side of this floor. There's also a large exterior door to allow large equipment to enter easily this floor. The conference room is on the very north side of this floor, directly over the entrance. On the second floor, we will have a spray dryer room, which will hold our existing dryer, as well as the new multi-stage dryer, to give us great capabilities in making a wide range of dairy ingredients. The south side of this floor includes a high bay area that has 30-foot ceilings where these dryers will reside. Here are some images of the new dryer arriving at the facility and being installed into the new building. We also have an evaporator and a wide range of membrane filtration units on this floor, and this also includes a product cooler area. We are adding a new program area to allow us to make small batches of UHT or extended shelf life type of beverage products. The equipment includes both direct and indirect UHT, and packaging includes both bag-in-the-box and 250 ml plastic bottles. The cultured products area will include fermenters, separators for both cream cheese and Greek yogurt, as well as a pouch filler. The second floor conference room will be used for industry meetings and other events. It is just off the CDR reception area, and it is right above the entrance area to the building. It will have windows in both the north and west sides of the room. The old CDR office areas are being renovated and expanded to provide offices for the growing CDR program. The observation area, or overlook over the University Dairy Plant, will remain for visitors to see Babcock Hall and look at ice cream making. The ground floor and first floor CDR pilot plant areas will be opening this fall, and we look forward to welcoming you to this world-class facility. And a special thanks to many of you that were donors and supporters of this project.
So an exciting video of progress on our project. And now I'd like to pass it over to Mike Bertram from the Arlington Agricultural Research Station for an update about that program. Thank you.
All right, thanks, John. I'll get into talk a little bit about the history and background of the Arlington Station and some of the research that we have going on here. We trace our history back to the Arlington campus. There used to be a 600-acre farm on the west side of campus, and after World War II, they decided that it was with encroachment and population increases, they needed a larger area and outside of town. So they sold that and purchased 13 farms between Arlington and DeForest, about 1,800 acres, and started the Arlington Station. The farm off of campus was the Hill Farm, and it became Hilldale. With additional purchases through the 60s and 70s, we got to our current size at 2,037 acres. And most of it's in Columbia County. There's about 100 acres in northern Dane County. Breaks down to about half is used for research and half is used for production for crops for feed for animals. Of the major crops, we have about 800 acres of corn, 300 acres of soybeans, 400 to 500 acres of alfalfa. Small grains amount to about 125 to 150 acres, and then pastures and a lot of other crops, including sweet corn, grasses, vegetables, sunflowers, and even tree research. In addition to all the research going on, we have about 85 acres of certified organic land that we're doing research on as well. It amounts to about 300 crops research projects a year with about 40 different researchers. At our headquarters, we are responsible for the field operation. We do many of the tillage, planting, pesticide, and fertilizer applications and harvest. We support the different animal units, and in addition to dairy, there's also swine, sheep, and beef units. We do the forage harvest, bedding, manure application for all that. We do trucking. We have a farm shop for doing mechanical repairs, and with the many buildings and animal units across the station, we also have a crew that maintains facilities. We have about 24 in our staff for the Egg Research Station, which, as I mentioned, some includes mechanics. It includes facility repair workers. It includes all the field operators as well as the management. And then we also end up with, or have about 8 to 10 students and temporary workers in summer to help get through everything. Next slide. So different ways we help support the dairy and animal units. The most visible is the feed mill. We do have an on-site feed mill at our headquarters. We process about 4,000 tons of feed annually, which includes all the units as well as campus dairy and livestock lab, sometimes other research stations, Charmony Farms, and dairy forage, depending on where feed is needed. It runs with a pneumatic air system, so it completely cleans out after each batch, and all the feed is done in 2-ton batches. You can see in the bottom corner is where some bakes and different additives can be added in, and next to that is the California pellet mill. Down also in the bottom is the fancy feed truck. So on Tuesdays, you generally see this going around campus, and otherwise it's going around mainly Arlington to the different units delivering feed. In addition, we also dry all the corn on the station through our corn processing facility, most of which is used for feed. We can store about 100,000 bushels of corn, and we routinely, a normal year, will dry 70 to 80,000. Next slide. Getting into some of the research we do, and specifically dairy related, first would be on the nutrient side. One of our newest things that we haven't really got much chance to try out is the tanker additions up in the top corner. Onto one of our manure tankers is added Harvest Lab near infrared type system that will scan or analyze manure on the go for the nutrient content, and then we can adjust the rate based on what the nutrient analysis is and what the rate is needed on the field. So that's a new research project that's just starting out with Matt Digman. Also on the top is Paired Watershed that Francisco Arriaga started in 2013. The first 4 years they compared liquid dairy manure side by side with applications on frozen ground in December versus late January on snow-covered ground, and it measures everything that comes off from rain or melt events. The next 4 years they measured solid versus liquid manure in winter, and there'll be a new study starting this coming year on there. Across the bottom, it shows one of the soil science studies that you can see obviously where the nitrogen was lacking on some of the plots because they're a little bit more yellow. And then it's showing a dragline operation, which is how we put out a lot of our manure. Next slide. A lot of forage research on the station as well. We have the Wisconsin Integrated Cropping Systems trial, which has some grazing research with dairy heifers. There's a lot of forage hybrid and variety testing, which is shown on the top with some of the corn. Bunker management has been a focus of research with different densities of silage. The chopping one in the middle is of a trial that had different fungicides in timings on alfalfa, and then there's been a lot of different bale research as well. Next slide. And then another major focus is the outreach. We have a 500-seat public event facility where we can do many different types of presentations. On top, it's showing one that with egg safety and showing how to free someone that's trapped in grain. On the bottom right, it was one of our field days with a large crowd, and then the bottom left was pastures at the Wisconsin Integrated Cropping Systems that had a tour this summer. And then final slide. One other forage project is the Wisconsin Alfalfa Yield and Persistence. We've been a member or a participant in this since 2013. It's tracked alfalfa yields and quality off of 120 fields across the state, over 64,000 acres. And if anyone needs any more information on that, I am the main coordinator, so I'd be happy to share what we've learned over these last 15 years. So with that, Jessica Cederquist is up next to talk from the Department of Animal and Dairy Science, and she'll focus more on the specific dairy research.
Thanks for that, Mike. So I am the research program director for the Department of Animal and Dairy Science. My focus is on ruminant species as a whole, but I'm going to talk to you specifically today about the Allenstein dairy herd. Next. go ahead and go one more. So I'm going to start today with Emmons Blaine Dairy. The Allenstein Dairy herd is a herd of about 1,400 animals, but spread across 3 different research facilities. The Blaine Dairy facility is on the Arlington Ag Research Station, and that is what I refer to as kind of our nucleus facility. It's kind of home base for the cows. That facility, we milk 500 cows there. We house roughly 100 dry cows and about 100 neonatal calves from birth to 12 weeks of age. This picture you're looking at here is just an overview of the facility. We have 2 different lactating cow barns there in the main part of the picture. Out back, you can see our new manure lagoon and our sand separation system, and then our calf pad and dry cow facility to the left of the picture there. So inside the barn, this is our milking parlor for Blaine Dairy. It is a double 16 parallel parlor. The one thing that is really unique about this facility is this facility was designed with research in mind. Everything we do at this facility is specifically set up for research projects. So as I go through the facility, you'll hear me talk a little bit about the numbers, and everything's done in multiples of 8. So double 16 parallel parlor. On the opposite side of this parlor, the holding pen is divided. It's divided, I can divide it into 4 quadrants so that we can bring small groups of research animals to the parlor at one time. We do have automated milk weight system here in the parlor and the ability to take composite milk samples through the milking process. Go ahead and move to the next. And then when you get out into the barn, this is our main barn. This is barn A. The picture on the left here shows some of our sand bedded freestall pens. We have in this facility, there's actually 2 pens of 64 on this one side of the barn, or they can be divided all the way down into 16 pens of just 8 animals. So we have the ability to really scale down the number of animals in a pen to do very specific pen-based research. You will often see these pens divided to just 8 cows or sometimes 16 cows. These pens are really heavily used for nutritional research, reproductive or lactation physiology research. But in this facility, we also have a camera system that allows us to do behavioral and welfare research in here as well. The picture to the right shows our maternity pens. We have 4 straw bedded pack pens for our maternity area. We do quite a bit of transition cow research in this herd as well. It's a very popular time for wanting to do research in these cows is during the transition period. And in these maternity pens, we have these blue feeders, which are the Incentec feeders. And I'm going to talk a little bit more about those and how they work because they're a big part of what we do at the Blaine Dairy. So the Incentec feeders is an automated feed intake system. The feeders themselves, those blue bins, are set on an individual scale system. So we are getting continuous weight measurements of what is in that feeder. Above where those cows' heads are, there's an antenna that actually reads the electronic ID chip in her ear. When she sticks her head in a feeder to eat, there's a gate that has her blocked off. But when the antenna reads her chip, it will allow the computer to recognize her, say whether or not she's allowed to eat out of that feed bin. And if she is, it'll drop the gate. It'll record all the information on the time that she entered the gate, how much feed was in there, and then also when she lifts her head to back out of the gate, it will record all the same information. It gives us the ability, not only can we measure individual animal intake throughout the day, but we've also been studying different things on meal size, animal behavior, how often does she eat, how many meals a day does she eat, if she has access to all 32 feeders, does she eat a little bit out of each one, or does she pick a favorite and always eat at the same location? So it gives us a lot of information and data. Our facility has had 32 of these, but recently, about 18 months ago, expanded and now have 52 feeders. And that expansion was made possible for us by the Dairy Innovation Hub. Move on. And so then here is our other barn. On the left is the bee barn, and this is where you can see the original 32 feeders that were put in at the facility here. This is in a lactating cow pen that houses 64 animals. And then the majority of the other pens in this barn, they're pens of 72 cows, and those are used more for animals that either are not on research or on research that doesn't require as much individualized data. The picture on the right is of our calf pad. Our calves are housed in individual hutches and then moved into super hutches after weaning. We do a lot of research at the calf pad as well. Earlier today you heard Dr. Jimena Laporta talking to you about her calf hutches with the solar panels and the fan system, and all of that research is being done right here on the calf pad up in Arlington. And then in the original picture, I pointed out our sand recycling building, and I just tell you a little bit about this system. This system we commissioned in December of 2016. It has increased our rate of sand reclamation to nearly 90% of what we're recycling. It has provided us with some really unique opportunities to measure manure gases and change the way that we manage sand. We get a lot more data and a lot more information in this building than we did before, and we've really done a great job with this system on increasing the amount of sand that we're able to recycle and put back underneath the cows versus what's going into ending up in our lagoon or back out on our fields. And in the next slide, you can kind of see the equipment from the side. The manure as it comes into the building, the sand is separated and picked up by an auger, which actually goes through a sand washing system where we're using recycled water from the parlor to actually wash our sand. And then the sand is stacked and moved before it can go back in under the cows. So in addition, our department has a facility right here on campus, and that is the UW-Madison Dairy Cattle Center. Right in the heart of the city, we have the capacity here for 84 lactating cows. Next slide. So our parlor here on campus is a double 6 herringbone parlor. This parlor and this facility in general is almost entirely staffed by students here at the UW-Madison campus. So we have about 15 students, undergraduate students, that are working for us right now, taking care of the milking and research and stuff at that facility. And then we have 2 different cow barns. This is a tie stall facility. So we have two different rooms in this building. Both are equipped with cool cells and fans. Really, we're able to keep the inside of this facility 15 to 20 degrees cooler inside than it is outside throughout the summer months. The cows are housed in individual tie stalls on pasture mats. And this is really the home to all of our intensive research. So at this facility, we are doing anything that involves really individualized cow data. So we can get individual intakes, stuff that might include total fecal collections or total urine collections, a lot of surgeries or biopsies taken at this facility, maybe jugular catheters. And these studies really span across all sectors, whether that be nutrition, reproduction, physiology. We're kind of doing it all here. The one great thing about the facility is we are farming literally in the middle of the city, which brings a whole different set of complexities. All of our feed is grown out at the West Madison Ag Research Station, or concentrate mixes made up at the feed mill in Arlington. We do have 2 silos on campus that our forages are stored in. The forages are stored in ag bags at the West Madison Ag Research Station and trucked to campus as we need them, and then blown up into the silos and re-ensiled when it arrives. We mix feed with a Ristler cart here on campus. And then the picture on the right shows a little bit about our manure handling system. What goes in must come out, and what comes into the city must also leave the city. So manure handling in the city certainly has its complexities. We do have a solid separation system that is able to separate the solid manure from the liquid manure. Some of the liquids are allowed into the Madison Sewer District, but all of the solids are stacked in stacking pads and trucked out of the city 3 times a week. So in this process, I have talked about our lactating cows and I have talked about our baby calves, but I have not talked about our heifers. All of our heifers are raised at the Marshfield Ag Research Station, so I'm going to turn it over to Nancy Esser so that she can tell you a little bit about where our heifers are raised.
Thank you, Jessica. And good afternoon, everybody. My name is Nancy Esser, and I'm the superintendent and the herd manager of UW-Marshfield Agricultural Research Station. And like those before me, I want to walk you virtually through the facilities at the station that I manage. You'll see in this photo, it's an aerial photo of our 950-acre research farm. This particular research station is located in central Wisconsin between the towns of Marshfield and Stratford in the heart of Wisconsin's dairyland. About 20% of all Wisconsin dairy cow operations are located in 4 central Wisconsin counties. Thus, Mars is ideally situated to aid the scientific exploration of key issues in agriculture, including farming some of the most difficult to manage soils in the state. We're going to walk into the first of several barns. We have limited time, so we're not going to go. Not going to be able to show you everything that I'd like to, but this particular barn, well, the Mars station in general is home to 575 Holstein cattle within the Allenstein dairy herd, as previously explained very nicely by Jessica. The animal research programs, just as an aside, in the College of Ag and Life Sciences are accredited through the Association for Assessment and the Association for the Assessment and Accreditation of Laboratory Animal Care. This is a voluntary accreditation process in which the college's research programs demonstrate their commitment to setting, achieving, and maintaining high standards for animal care and use and animal welfare in the pursuit of science. And I thought that was really important to just mention. Pictured is one of 3 heifer barns at the Marshfield Ag Research Station campus. And in total, as Jessica mentioned, the heifers in the Allenstein dairy herd are raised at the Marshfield campus. We have about 460 head of replacement heifers residing here at Mars. The barns are uniquely designed to house heifers into one of 72 research pens, each pen containing that number of 8 animals, a research unit of 8 animals. And as you can see on either side of the slide, drover's lanes run the length of the pens to facilitate animal handling and movement, critical to the research that we do here. You can see a green restraint chute in one of the drover's alleys in this barn. That's one of 3 that we own, critical again to the things that we do here. I mean, super useful in routine animal husbandry, such as tagging, vaccinating, healthcare, and so forth, breeding animals. However, incredibly useful to enable safe and efficient data collections from cattle, such as body weights, body measurements, fecal blood and urine sampling, and ultrasounding, or whatever the protocol requires. So this slide really nicely represents the cameras that were very recently installed. These cameras are capturing thousands of images of cattle that are on study daily to further develop computer vision systems for individual image-based body weight and biometric body measurement predictions. This work ultimately will help predict the future productive performance of animals. And there's an insert in the bottom of this picture. You can see how the animals are identified by a neck collar. That's something the camera picks up so that the study PI and the students working on the study are able to do something with that data. These animals were imaged while they were at the Blaine unit. We're integrated facilities, and those animals stay on study when they come up here. And in total, there'll be about 200 animals with images following them through their first lactation. The next slide is going to show a snapshot of outside of the barns. In particular, I'd like to point out that we have 115 acres of land dedicated to intensive rotational grazing. So for the last 10 years, animals at the Marshfield station have been on some sort of pasture-based study. And somewhat new to our grazing research portfolio at Mars is the Green Feed Pasture Machine, which you can see in this image. This is a Dairy Innovation Hub funded research piece of research equipment measuring greenhouse gas emissions. Specifically, the PIs on studies are looking at methane and carbon dioxide. Currently, we're also able to capture oxygen concentration from animals. And the system works, as you can see, it's solar powered. It also works by plugging it in, so it's used in conventional setting as well. But it works, it functions, it entices animals into that feeding chute by offering them some incentive. And in this case, it's alfalfa pellets to get them to the feeder multiple times a day to collect those greenhouse gas emissions. Now we're going to go back into the barn, and this particular barn is a USDA heifer barn. We have 63 electronic feeding gates installed to offer researchers the ability to gather individual feed data on animals. Feed efficiency studies commonly take place on cows and heifers, and Jessica had mentioned earlier the Incentec feeders. So there's quite a bit of this type of research happening within the university. The Dairy Innovation Hub capital equipment grant funded the cart that you see in this photo, which allows us to precisely measure feed fed to cattle on study and then go back and measure the refusals. Kaylee Reesgroff is pictured on the slide. She's a graduate student funded on a collaborative Dairy Innovation Hub assistantship between UW River Falls and the UW, and she's for research animals. And the last slide that I have is I'm going to try to pull everything together about our agronomy program with one slide. Mars operates on 750 tillable acres of land, and crops produced from the land support, of course, the everyday feed needs of the herd. And in addition, they support the work of the College of Ag and Life Sciences scientists each year in various studies. So on the agronomy side, there's generally between 50 and 60 studies exploring various questions in research questions, and that generally we're looking at forage species and variety evaluations, forage harvesting and preservation trials, soil fertility, conservation planting method evaluations, and cover crops and soil health type studies. Homegrown feeds also support dairy nutrition studies with 2021 funding from the Dairy Innovation Hub. Short-term high-impact study, research is currently taking place on the development of nitrogen recommendations for Italian ryegrass and dairy rotations, and that's what this snapshot is of Italian ryegrass. The study PI is evaluating nitrogen sources and rates through the seed to determine how these practices can affect yield, quality, and residual nitrogen on the forage crop. Another forage study funded through the Dairy Innovation Hub, and I know that had been talked about a little earlier during today's program. The study PI is Matt Akins, and he had a study funded exploring the performance of lactating cows when fed a cocktail forage mix. And then if you missed that, or just to summarize, those objectives were to evaluate the impacts, and it's currently taking place in our feeders. He is evaluating the impacts on intake, production, and digestion when cows are fed cocktail forage mix in place of the conventional hay portion of the diet. And the cocktail forage mix consists of BMR, sorghum, Sudan grass, Italian ryegrass, a couple different types of clovers, and vetch. So that kind of wraps up the Marshfield tour. It's just a snapshot of our facility. There's quite a bit more. And I hope to have conveyed to you the uniqueness of the satellite research farm and how Mars has been impacted by the Dairy Innovation Hub. I thank you for your attention, and now I'll hand it back over to Maria.
Great, thanks Nancy, and thanks to our earlier presenters. We do have some time for a couple of questions that came through. So I'll start with John Lucey from CDR. We loved the video. When are you planning to move in?
We've been starting to move in over the last week or two, and by this weekend we will take over 2 floors and start using those 2 floors. Those 2 floors will be primarily for things like our training areas for short courses and extension type activities, and it has a kitchen as well in it. And also the cheese making floor will be ready for operation. So there's still a lot of training and setup of equipment that's ongoing. But by this weekend, we will be taking over 2 floors. There's one more floor of process area, which will be like powders and beverages and things like that. That'll be a couple of more months as we wait for some equipment to be installed.
Excellent, thank you. I guess this would be a question for all of our panelists. What would you say are some of the biggest discoveries that our viewers might recognize that took place, or that were discovered, researched heavily at your facilities?
I guess I can kind of target some. I mean, we do such a wide range of different things, but I would say looking out to the farmers that are with us today, OffSync would be one that is used globally in the dairy industry really heavily on a regular basis, and a lot of that research started right here in the animal science department, animal and dairy science department here at UW-Madison. So I think there's a lot of things that we've done with research around everything that we do in all different aspects. But I think for me, that's one to be cool that we were part of the original start of that.
Anyone else want to share?
I would like to add something, although I think there's a lot of things that could be brought up, something that is hands down something that everyone can relate to are the calf hutches, raising animals individually, and this goes way back a couple of dairy scientists ago, where Dr. Howard Larson, just by virtue of just happened to stumble upon separating dairy calves to protect them from, or prevent them, isolate them from those developing immune systems, separating them from the barns, and it just happened to notice that it improved mortality and morbidity, and it became something that's, again, a very global accepted means of raising animals that really changed how animals were raised. I know that's quite an old discovery, but it's one that I think everybody can relate to.
Well, the next generation of that, Nancy, is group housing, right? And that's also something that has been discovered at UW-Madison.
Right, absolutely.
Probably you had a part of, yeah. Anyone else?
Right, I was just going to mention, you know, the thing I think we're most proud of here is our role in the growth of the specialty cheese industry here in Wisconsin. You know, when the CDR started back in the early 1980s, about 2% of cheese was specialty cheese. Here in the state, we were really known for commodity products. But as of today, about a quarter of all cheese made in Wisconsin is specialty cheese. We make hundreds of different styles and types. And, you know, we do a lot in the background for that in terms of short courses. We have a specialty cheese training program, and we developed the Master Cheesemaker program here, which is the cream of the crop in terms of training our cheesemakers as well. So we look at that as continuing our kind of efforts to drive that forward with our specialty cheese program areas. And you saw in the video there, those 9 ripening caves to really accelerate development and understanding of specialty cheeses and how they develop in terms of flavor and texture. So I think that's an ongoing kind of thing that we're really proud of.
How about you, Mike?
Some of the early equipment research was done here through the Department of Biological Systems Engineering, particularly like the pull type forage harvester. Some of the prototypes came out of here before they were taken by out to the companies to further develop into some of that, which made agriculture a lot more mechanized and easier, more efficient through the mid-1900s.
Well, thank you again to all of our panelists, and you know, thank you to all of you who were listening and hung out with us for the day, or maybe just popped in and out. Thanks to Mark Rickenbach, who gave an introduction earlier.